At Cardiocentro Lugano, the foundations have been laid for an original project developed by members of the non-profit organization Bambini Cardiopatici nel Mondo, active in developing nations. The idea was triggered by the need to guarantee remote assistance to technicians and physicians operating in distant countries. This project is virtually defined as telepresence. In other words, remote communication allows you to operate virtually there where your physical presence cannot be assured. The project takes its cues from enhanced reality, a technology allowing you to add computer-generated information to the commonly perceived reality. We developed and patented this technology, which allows for the creation of a sort of hologram. In this particular case, the application field is quite recreational and commercial, but the idea is to add information sourced from a computer and merge it to the commonly perceived reality. But if this same technology is taken advantage of whilst using telepresence, we are able to include technical or any other sort of information to the images. Hence, the idea of miniaturizing this technology inside special glasses which allow the person wearing them to, for instance, visualize helpful information superimposed to the reality perceived through its lenses. An engineering firm based in Arzo was able to create this technology following meticulous research and engineering activities. The idea is to supply these glasses to so-called non-expert users who, by just wearing them, besides having a perfect vision of reality through the glasses' plain transparent lenses, will also receive information and instructions from the other user who may be at kilometers distance. Whilst waiting for the first prototype's tests, another type of similar glasses have been developed. The only difference is that instead of seeing through its lenses, the vision is enabled by two micro cameras, allowing one to see the surrounding reality and sharing it remotely. The glasses have two monitors operating in an independent manner for each single eye. Their key feature is that they are fitted with an inbuilt gyroscope detecting even the smallest movement of the head, and this allows to perfectly focus on the spatial information forwarded in a remote manner. The person providing the instructions wears the same type of glasses without the micro cameras. In brief, this is how it works. Let's imagine we are in a hospital 5,000 kilometers away from Lugano. The radiological system of the cardiac catheterization device broke down, and local staff are unable to fix it, and thus ask for assistance. Video and audio contact can be established with the remote expert through the glasses connected to a microcomputer tracked over their shoulder and the internet. On the other end, in Lugano, also the expert is wearing his glasses and thus exactly sees what the other person who has to repair the device is looking at. It is at this point that the real interactive part begins. A motion sensor detects the gestures the expert performs with his hands and transforms them into digital signals which are then forwarded remotely. Through the use of a sidebar, these signals can be displayed in the shape of a pointer or any other tool. So the person receiving assistance just has to follow the pointer's movements. The development of this sophisticated system took 3 years. The aim is not to confine telepresence to a merely technical type of assistance. In the very near future, it shall be possible to diagnose illnesses remotely and perform surgeries with the help of an external consultant who, as said before, might even be at the other side of the globe.